Going live, we are live. So, there we go. You guys are my eyes. We're going to continue on with 4.3, logarithmic functions. Okay. But today, I think we're going to start talking about graphs. So we'll talk about f of x equals log is 2 of x. Now, before we start talking about the graph, we remember that exponential functions and logarithmic functions are inverse functions. Okay, so that's going to hopefully help us to graph these. Now, if this is the function, how would we write that in exponential notation? How do you know how to do that? Not as a fraction. So your base is 2. So we're going to use that as our base, right? It's actually 2 to the y. We equal x, okay? So that's how we would write that as an exponential notation. Now, rather than graph that, what I'd really like to graph is I'd like to graph y equals 2 to the x, okay? And then we're going to use that to help us to graph y equals log base 2 of x, okay? So, if you remember how to do that, graph y equals 2 to the x. What are the two things we need to remember? Two properties. You don't remember the properties? Do you remember how to graph it?
I remember points.
Is that all you remember?
Right now, yeah.
Okay, shall we?
Are you saying you want to divide 2 to the y equals x over that, or is it? I'm just confused. Well, it's like written under there.
Oh,
or you just want it written that way, or?
I want to graph this because it's easier to graph.
Okay.
Than that. Okay.
So are you able to just switch the variables like that?
No.
Okay.
This is a different problem than that.
Okay.
So yeah. These are not related necessarily. Okay? But does anyone remember how to graph y equals 2 to the x? Because I hope you do, because we basically did that on our quiz spectrum. James, remember? Without plotting points? Oh my gosh. Was I off the quiz today? I can't remember. I didn't look at them closely.
It's 0, 1, and goes up like that.
Okay, so you got your important point, right? Important point is 0, 1. And so 0, 1. Okay. What was the other thing?
The asymptote is 0.
The asymptote. Okay. The asymptote is where?
0. Right?
0 is only half correct. Y equals 0. Okay. So those are the two things that Tyler's not going to forget on tomorrow's quiz, right? Okay. So I've got my asymptote here, and it looks like this, right? Roughly. Okay. Now, the next question is, okay, so we know that these are inverse functions. Okay, this kind of goes back to Nathan's question. What do we remember about inverse functions? So we're going to swap the x and the y, right? X and y. Is there anything else we know?
Inverse is basically a reflection of the y equals x line.
My other class didn't remember that. I'm impressed that you remember that. Okay, so it's a reflection over the y equals x line. Okay? That's very, very important. Okay? So now we're going to go back to Tyler's method just to prove a point here. X and y. So what are some good points that I should pick for y equals 2 to the x? How about Zach?
Y. Oh, 1. 1 negative 1.
Let's go 0, 1, negative 1,
And then negative 2.
2, and negative 2. Okay? So x is 0, y is 1. Y equals 0. X equals 1, y equals 2 to the first power? Yeah.
Oh. 2.
2 to the minus 1 power? 1 half. 2 squared?
4.
4. 2 to the minus 2?
1 4.
1 4. Okay? And we'll make sure these are plotted okay. In fact, I might have to change my scale a bit. So 0, 1, 1, 2, probably should go up there. 2, 3, 4. And we'll make this a little steeper. Okay? Negative 1, 1 half, and negative 2, 1 4. Okay? All right, so that's how it should look. All right, so if these are inverse functions, then here's what we're going to do. I'll use green for this. Okay? If we were to use the same points, what would we do with our xy table?
Swap the x and the y's.
Swap the x and the y. So this point becomes
Oh, 1 0.
1 and 0. And the second point will be
2 1.
2, 1,
1 half negative
1
1.
half, negative 1,
4 2.
4, 2,
1 4th negative 2.
1 fourth, negative 2. Okay? So all we're doing is we're swapping all of those. Okay? Now, all right, so if I've got 1 0, okay, so here we go. So these are properties for an exponential function. Now we're going to have two properties for a logarithmic function. Okay, so what do you think these two rules are, James? We just said that. I know, that's why I picked them. Okay, so we've swapped all the points, right? So my important point is going to be what?
Is 0 negative 1?
Nope.
Or 1 0.
1 0. And now my question is, we didn't talk about this. Where's your asymptote? Well, my asymptote for this was y equals 0. So my asymptote for this is going to be x equals 0. Okay, so now I've got a vertical asymptote rather than the horizontal asymptote I had before. Okay, if I go ahead and plot these points, I've got 1 0, 2 1, 1 half, negative 1. 2, let's see, 4 2, 2 3 4 2, and negative 1 and 1 4th negative 2. So you can see that if we, as Michael said, if we fold it over the y equals x line, we've got a mirror image over that line. Does that make sense? Okay. All right. So that's how that works. So the three things that I would really like to see on Monday's quiz. I want to see this point. I want to see this asymptote. And I want to see the basic shape of the curve. Okay, does that make sense? Now, somebody in my other class asked a good question. And I want to spend a little bit of time on this. Oops, what happened? This is really annoying. Okay, so here we go. I want to compare y equals log base 2 of x with y equals log base 5 of x. And if we're plotting a point, we should probably be careful about which points we're going to plot. Okay? So I want to graph both of those. Graph them here. And just to kind of compare, what do you think that the question he asked was, what does the 2 do and what does the 5 do? Does anybody have any ideas? What does it do to your curve? We know that our basic curve looks like this, right? So what does the base 2 or the base 5 do?
How sharp the turn is.
How sharp the turn is, okay? So let's talk about this. We use Tyler's method, but I'll have Cameron Harward this time pick it. What are some good points to pick if you're going to plot points for y equals log base 2 of x?
0.
0. What is the log of 0?
Log of 0 is 1.
Nope.
No.
Go ahead and type it in your calculator.
Undefined. There was an answer.
You're stealing all my thunder here. My other class, they said it's error. Error is not the correct answer. It's undefined. Y is 0 undefined. Okay, we got to have somebody besides Michael answer. Yeah.
Is it because you're never going to reach 0?
Right, because where's my asymptote?
Is that 0?
0. So you can't get a 0. That's why I put an asymptote there. Okay, so 0 is not a good point to pick. What's another point to pick?
1.
1. What's the log of 1?
0.
0 in any base, right? Now let's be careful about our next point. What's the next point you want to pick?
2.
2. What's the log base 2 of 2?
1.
1. What's the next point you want to pick?
4.
4. Why did you pick 4? Because it was a guess.
Yeah.
It was a good guess. Why is 4 a better option than 3?
Because 2 can't go into 3.
2 can't go into 3 evenly. We could write 4 as 2 squared, log base 2 of 2 squared, right? And then I can pull this 2 out front. What's the log base 2 of 2?
2.
Log base 2 of 2 is 1, but I'm going to multiply it by that 2, and I'm going to get a 2. What would be another good point to pick?
6. 8.
Let's go with some other numbers. How about -1? Would that be a good one to pick? Usually we try to go with integers, right? Is -1 a good one? It's on the other side of the asymptote, so that would not be a good choice. What is the log of -1? Also undefined. What about 1/2? What's the log of 1/2? did that without a calculator. Most people did a calculator. Why is it -1?
Something raised to the power of -1 is a fraction.
I could write this as log base 2 of 2 to the -1 power, right? So the idea here is you're going to use multiples of, in this case, 2. Okay? Would 6 be a good one? No. We probably want to, okay, so I've got -1. All right, so this is enough to do what I've got here. So it's undefined with 0. I've got 1, 0. I've got 2, 1. I've got 4, 2. I've got 1/2, -1. And the idea here is it's going to go like that. Okay? Now, let's pick on Demi. Can you tell me some good points to pick for this blue one over here? Log base 5, the terrible looking 5, of x.
1.
Log of 1 is?
Yeah.
Okay, what's another good number to pick?
Would you want to give multiple to 5 and not 2? So it's 1.
5. Log base 5 is a 5? 1. What would be another good number to pick?
Do 10.
Is 10 a good number to pick? 10 is not a good number to pick. 25 would be a good one to pick, right? Log base 5 of 25 is 2. That's 5 squared, right? How about 1/5? That would be -1. Okay? So once again, take multiples of 5. Okay? And so it's still going to go through 1, 0. It's going to go through 5, 1. It's going to go through 25, 2, which is right here. It's going to go through 1/5 and -1. Okay? So in this case, it's going to go, you can see it's a little bit steeper. Okay? So do you see what the difference is between the bases there? This one's going to get flatter faster, right? Okay, so that's basically the difference here. So as we're looking at these, I just want to see this basic shape, the point there, and the asymptote. Okay? All right, let's do another one. Let's start shifting stuff around. What would be g of x equals 2 plus the log base 5 of x. Okay, we want to graph it. We're going to try to do it without plotting points. Jeffrey, it must be your turn. What do you think this? So where do we start normally?
We start at 0, 1.
0, 1, or 1, 0.
But this one goes
We're going to start here, okay? That's where we're going to start. What does this 2 do to me? Can shift it upward? Are you sure? Okay, good. Upward 2. Okay. What's that going to do to your asymptote? It's also going to shift it up too, but when it's a vertical asymptote, you don't notice anything, right?
Yeah.
Okay. So we've got our asymptote here, and we've got our important point here. And what does it look like? High to low, low to high.
Low to high.
Okay. All right, yeah, just like you drew, okay? So that's what we're looking for. How about this one? What if I said h of x equals log base 10 of x minus 3? No, there's something else we should have done, but we'll finish this thought first. Nathan, what do you think?
Which one?
We're going to graph this one. It's going to shift 3 to the right. So rather than be here, we're going to go 1, 2, 3. Okay, that shifts my important point 1 unit over here, right? So now I'm at 0, 4, or excuse me, at 4, 0 rather than 1, 0. Okay? What does that look like? Like that?
No.
No?
No, it'll be like that. So I actually really don't know.
Won't it be more narrow though? Because it's.
Oh, you're right. Because of base 10.
I mean, I guess.
I'm not going to worry about that too much, but yeah, it'll definitely be steeper than this one. Okay? But is that what you meant, Nathan?
Yeah.
Okay. All right, so it's a little, yeah, it's going to flatten off faster. Okay? What if I had g of x equals log is 10 of 3 minus x? What do you think, Andrew? Or would it be better to write this as negative x plus 3? Log is 10, negative x plus 3. Would that make any difference? Is that the same thing? Who says it's the same thing? Who says it's different? Why is it different?
Because the x is negative 3. So it would shift it to the left 3, and then it would flip it.
It's actually the same thing.
Is it really?
Yeah. Okay. 3 is still positive. The x is still negative. Okay. Now I'm going to warn you guys. I actually did this wrong in my first class because I didn't pay attention to the domain. In fact, let's go back a second. Before we answer that question, what's the domain here? Holly, what do you think? It's infinity? Cameron?
Would it be infinity to, or 0 to infinity?
0 to infinity. What am I missing?
Brackets in it as well.
Is it square brackets?
No, just curves.
Round. What else am I missing? X. X is an element of, right?
Yeah.
Don't forget your X. Okay. How about this one? What is your domain? Let's be Natalie's turn. She's not looking at me. I must be thinking of the wrong name. In the gray sweater. Tell me your name. Nicole. I got the N right. Nicole, what's the domain on this one? Looking at the graph. The same thing, x is an element of 0 to infinity? I don't think so. Is 0 in my domain? So it would be 3 Can't hear you. 3 to infinity. What did you forget? Parentheses. What else did you forget? X is the element of, okay? All right, so let's talk about the domain for this one here. Okay, and I think it might be more helpful. So what is the domain in this case for this problem here? Or this problem, either way, I don't care. Let's pick on Eunice. Uh-huh. No idea? Okay, so let's look at this. Here's what I'm going to say. Can you take the log of a negative number? No. So 3 minus x must be greater than 0, correct? Do you agree with that? Okay, how would you solve that? You add x to both sides, right? So x would have to be less than 3. Does that make sense? Okay. Now, where's your asymptote here? I told Joey I was going to pick on him first yesterday. I'm glad you're coming back. Actually, I think I did pick on you. It's going to be 3, right? 1, 2, 3. Okay. And all of my x's have to be less than 3, right? Okay. So let's go back to this. Where's my important point? Normally it would be here, but this is going to shift at how many? It's going to shift at 3, 1, 2, 3. And shift it there. But is that in my domain? No. And I also have a negative x, or a negative x. What does that negative x do to me? Flips it how? Over the asymptote. So I'm still going to be 1 unit away, but I've got to be 1 unit over here. Okay?
Why is the asymptote negative 3?
Why is it not at negative 3? Because of my domain. So it's got to be, x has to be greater than, x has to be less than 3, right? Okay. Now, if this looks like this, we're flipping it over the asymptote, right? So how does my curve look? Still asking you this. You were hoping I was asking Demi, huh? She's glad I'm still asking you.
What's the question?
Okay, normally your curve would look like this. But because of my negative x, what happens to my curve? It's going to flip over mirror image on the asymptote. It's going to look like this, right? Or rather, like that, right? Because it's a base 10. Okay, does that make sense? Okay. So we do a couple more of these. These can get a little tricky. Okay. How about if I did g of x equals negative log base 2 of x. What do you think that negative does? Oh, it's a good thing I picked on Nicole. Demi, what do you think?
Would it asymptote would still be at 0.
Asymptote still at y at x equals 0.
And then your important point would still be at 1, 0.
Still going to be at 1, 0.
But would it go like this?
Oh, very good. You can flip it this direction, right? Okay. How about y equals log base 2 of negative x? How does that look? Cameron in the back, it must be your turn. We'll draw it on the same graph. We're doing y equals log base 2 of negative x.
Would it flip over the asymptote?
Would it flip over the asymptote? I don't know. You're doing this problem. How confident are you in that? 80%. Okay, who agrees with Cameron? Okay, so it's going to flip over here. And what does it look like? If this is our normal, you can't see that on there. This is what it normally would look like, so it's going to look like
It's gonna rise to the bottom and go up.
like this,
Yes.
or like that. Okay? Who agrees with them? Anyone disagree? Okay. All right. Oh, let me ask one more question, and I'll let you guys go. What's your domain for this one? Let's pick on Demi. Must be Demi's turn now. Oh, I already picked on Demi. It must be Maddie's turn.
For the blue one,
The blue one.
it would be negative x.
Negative infinity to x,
Sorry, 0.
0. And it's round and round, right?
Yeah.
X is an element of. Now, how did you figure that out? You looked at the graph. Okay. that was helpful. The graph is definitely helpful. If you weren't looking at the graph, how would you figure this out? Figure out the domain. Lauren, it must be your turn. Do you know how you'd figure out that without looking at the graph? I'll try to block the graph. Do you know, Maddie? Okay, remember, whatever's inside the parentheses, negative x has to be greater than 0, right? So how would you solve that? Multiply by a negative, right? And when you multiply by a negative, x would have to be less than 0, which is the same thing that Maddie did. Okay? So the domain, that's going to be, that is definitely something that trips up people on the quiz. So, Quiz Monday, we did not finish this section. That's okay. I'm trying to go slower on logarithms because students struggle with them. So as far as homework, we didn't talk about base 10 logarithms, but those are pretty easy. I'm going to say your homework is up through 34. And so we'll see you all on Monday.
Tell you about the